In an effort to gain an essential understanding of the concepts of electromagnetism, I chose to make a simple railgun, which proves and demonstrates the Lorentz force law and Ampere's law. Though the results were a little underwhelming and I stumbled on many pitfalls along the way, the lessons I learned through failure were extraordinarily valuable. The railgun demonstrates the Lorentz force law in particular, which is the cross product of the current over a length of a conductor and the magnetic field. Creates a kinematic force with magnitude and direction. The magnetic field is amplified by the magnetic field created by the current through the wire, which is determined by Ampere's law. And knowing your right-hand rules should point in the same direction as the magnetic field created by the bar magnet. My original schematic was a simple one, using a 9-volt battery, some aluminum rails, a long bar magnet with north and south poles on the long flat-sided surfaces in order to create a uniform magnetic field, and a small steel cylinder and some capacitors set up in a parallel array. The force should be enough to move the projectile. I set the loop so the current travels counterclockwise and the magnetic field points upwards. So using the right-hand rule for Lorentz force law, the force should point forward. And also the aforementioned Amperian loops pointed upwards on the inside of the rails, which increase the magnetic field as the current increases. The first pitfall I encountered was with the 9-volt battery. It has a built-in resistance, so not only did it fail to create a high current, it also got dangerously hot. I eventually utilized the lab's bench shorts in order to overcome this. The next problem I encountered, but should have probably recognized previously, is that steel is a paramagnet, and even if it felt a force from the current and magnetic field, it would attract the magnet with a much higher force. So it would move slightly and then stick to the track. So I switched out the projectile to aluminum, which is much lighter and isn't a paramagnet. Also, the initial rails I used were an L-shaped aluminum beam, which had an asymmetric cross-sectional region, so the current density was unpredictable. I replaced these with aluminum dowels, which had a uniform symmetry. I was wrong in almost every aspect of my original schematic, but I really learned valuable lessons in materials and electromagnetism. Even after all of this, the railgun was pretty unimpressive. The projectile never really reached high magnitude of velocity and often would weld to the rails, causing scoring on the surface of the rails, which probably created some frictional coefficient and yet another unexpected variable. If I were to build another railgun, given the time and resources, I would use a much more powerful energy source and set up a mechanism to give the projectile an initial velocity. Also, I would use capacitors with a much higher capacitance in order to dump a much higher concentration of charge on the circuit. All in all, this was an eventful, enjoyable, and educational application of the scientific process, and I really appreciate the knowledge I gained and applied throughout this semester. It is really one step closer to achieving my aspirations of being a full-time science wizard, or a more acceptable title of engineer. Anyways, it's been fun, and I hope you'll enjoy some of the videos I took of my scientific adventure.
Oh, you globbed it, bro.
I did glob it.
Okay.
But you...
What the fuck?
Alright, hold on. Okay.
Alright, tell me you're ready.
Yeah, ready.
You got a real good video. Tell me when.
Alright, go.
That's not. Alright, give it a roll. Tell me when.
Go. Okay, do it.
I need to find. Tell me when.
Go ahead. Do 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 da, ba, 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 ba. Let's blow some shit up. Oh, super disappointing. Alright, let's make some shit fly. An exercise in futility.
Two, one.
Wee. Yay!